record. Okay, so welcome to Thursday, week 5, day before assignment 1's due. That's something I forgot to check. How many people had submitted the assignment? I can do that. I'll do VaxDB. Don't forget that's an alias that logs me into this, to d.csv. Thursday. All right. So there's some stuff already. What was the underlying cause of give command not working? It was the fact that some of the so when you do a give, it has to go and look at the SMS database to find out what tute you're in, and the command that did that hadn't been given the right privileges on d.csv. So it went and looked, didn't find a tute, and for anyone who doesn't have a tute, it puts your submission under a directory called orphans, which we can have a look now as I go and check. Oh yeah, the other thing I want to check here, let's see, how many people are logged in working on the assignment? Oh, probably should have used uptime. Only 17, you see, I knew it. You guys don't get up early. There was 120 at 5 o'clock last night. So, what is that? Right. Yeah, all right. So if I go to assignment 1, so there's directory for each tute. There's also a directory where other things go. And I want to check that directory to find if people are still submitting there. Who is this person? October 13th, 2 o'clock. So yesterday, someone did a give from d.csv, and all these other people have 2. Yeah, tempting. I'd need to tell them first because they might think they've submitted. Few of these people have submissions elsewhere. So they've obviously submitted from d.csv and from some of the other one of the other hosts. So any of the VLab hosts, you know, VX5, VX2, VX7 will work. Any of the big logging servers like Wagner, Williams, et cetera, will work. Those big logging servers, though, you can't actually run. You can't run gedit and any kind of graphical type thing. You can run jihad at any, yes. Thank you, transcription. When do you want me to check? Wednesday, 11A. All right, are you there, Maria? I assume you are.
No, it's not there. B then, Wednesday 11B. What?
Oh,
I submitted mine.
All right,
yeah.
all right.
Oh, no, it's there. That's mine. That's me. Yep. Okay, I found me.
All right, happy. But yeah, I think I'll start emailing people like this who are still submitting on d.csv during the week. In fact,
honest with you, I don't think they know how to do it because I think they're confused.
Well, if they do it through web CMS, it should work properly.
I don't think they know. I don't think they know what that means.
Right.
I know.
It's a bit sad, really, isn't it? What are we? Level 3 course, and people still don't know how to submit assignments. I don't know how they manage to submit assignments in years 1 and 2. But anyway, all right. I will repost some information about submission tonight. One thing I did want to check though, is that just to have a guess at how many people have submitted. Now, of course, these aren't necessarily all submissions, 180 out of 550. Well done, everyone's left it to the last minute. Good luck. D.CSC or VXDB didn't seem to be struggling with 120 people logged in, all running Postgres servers. So hopefully it can handle twice that load, which is likely to happen today and tomorrow. Could you scroll up a bit? Why? Do you want me to look at a particular week, a particular shoot?
Yeah, she does, because I think she was the person that had an issue with the submission. Yeah, it's Selena. Yeah, I remember Selena. You had a, yeah, look, yeah, just check for her, because I think she.
Are you there? Good. All right. What's the date on the submission? So hopefully it's the most recent one. Occasionally you find people who's got a submission in orphans also have a submission somewhere else, but the submission in orphans is the later one. So maybe they think they've submitted a new version. Aren't you able to submit multiple times? Yes. Sure. Yeah, you're right. Okay. So I'm sure that not all of those 182 are actually final submissions, which is even more concerning. If only half of them are final submissions, then there's still 400 people who haven't finished yet. Pretty sure it gets overwritten. It doesn't get overwritten. We keep a number of submissions. I think it's up to 3, the 3 most recent submissions, and the final one is the one that gets marked. All right, I've got rid of my magic mouse, which was starting to annoy me. Okay, enough of that. All right, where am I? PWD, I'm in the right place. Good. Always 18 news that someone else has woken up and started work. All right, so today I wanted to finish off a couple of things about PLPGSQL. You should be looking at the what I call the content videos anyway for all this info. It does it in more detail. And I think the notes might do it in even more detail. And then talk about some things that rely on PLPGSQL. So aggregates, assertions, and triggers. When I say rely on PLPGSQL, they actually rely on being able to define functions in Postgres. All right. So last time I was talking about a few extra things about PLPGSQL. So select into allows you to grab values of attributes in a tuple and store them into local variables. Now, I'll show you what the effect of this is. So if we had a if we had 3 local variables, z text, let's say that, and then inside here we could do from some table, blah, blah, blah. So that would, for each, in fact, if you do select into, it does it for one tuple, which will be the first tuple that the query returns. And if you don't put an order by on, then you're not sure which tuple it's going to be. Of course, if you're smart, you'd use a where clause that selects only a single tuple by giving a value for primary key. So that's one way that you could do this. This is pretty much equivalent to, so imagine we got a record of type R. The other thing we could do is, I still have to do a select into. That's annoying. All right, let's imagine that we're doing this for rec in. Not quite the same, because this is actually going to look at all of the tuples, unless I quit the loop early, which is possible. And then if I did, oops, I'll fix up my assignment in a moment. So that select into is kind of like doing that. So selecting an entire tuple and then grabbing the individual attributes and storing them into the appropriate local variables. And if I wanted to escape that loop early, I think there's an exit statement to get out of a loop. Seems a bit silly doing it in a loop anyway, but there you go. Really just to illustrate the point that if you've got a whole tuple of the appropriate type, then you can assign the values of attributes individually, or you can do it like this, which is probably the smarter way to do it if you know you've only got a single tuple. All right, just stick. Obviously, that's not syntactically correct. Right, so that's select into dynamic queries. You can build up queries as strings and then use the execute statement to run the query. I showed some examples of that last time, but basically you tend to build up query strings using the concatenation thing. So you've got a partial query, concatenate with some value that you want to stick in the query, then concatenate it with the rest of the query, and then execute the string actually rather than. Let's see. Declare query string is just a type text. From well, actually, I should show you something interesting. And someone suggested, why do you need to do this at all? And you're right, inside PLPGSQL functions, you can actually embed values into queries directly if you write those queries at the top lexical level. I'll show you what I mean. Where E equals I don't know. Ooh. Damn, I should have looked up things. All right, let's try this. There's two functions for inserting values into these query strings. So that will either put quotes around the 5 if it needs to, or it will just embed it like that. And then I can go execute toString. Let me just check. Quote literal. Quote, not quote, literal. Yes, thank you. Quote literal. All right, yeah, so quote literal basic statements. And this is only for PLPGSQL by the look of it. In terms of strings, suitably quoted to be used. All right, better open this up. Oh, it actually, all right, So there's a whole lot of different ways you can format things in Postgres. As you can see, Postgres has an extensive manual, which is worth learning how to use. You'll have it in the exam. All right, so quote literal will basically sort things out. Oh yeah, all right. So if I had, what have I got? Execute Q string. And in fact, I can do into rec, and that would grab the first tuple from this query and stick it in the variable rec. Now you may notice over here that there's also a thing called quote ident. So another example is if I had a table that I wanted to query, and here I'm just assigning a constant value, but the value of table could easily be set from a parameter, which means you can have a function that you pass in the name of a table and then it executes query on that table. So once again, let's grab. I mean, this looks silly because I'm using constants all the time. In fact, I won't. Number is an integer and it's going to be set to 5. Table text value that I'm assigning here. So quote literal will put the value 5 into that string in an appropriate format. And this, that's what I wanted to. Can use table as a var name. Kind of. This is what I'm trying to do here is show how you can actually embed a table name into a query string. So if I do that and then I can execute that query string, it's actually going to produce the same query as I had above. And in both cases, the query string that's actually produced looks like this. It actually quotes 5, I'm pretty sure. And of course, you could always write that in Postgres if you're writing it at the very top level. So I could do something like this for, let's imagine I've got a variable of type record. Oh, whoops, that wasn't what I meant to do. I meant to say number. So there's a little bit of subtlety here. We're talking about different contexts. So in, if I'm trying to build a string, a query as a string, then I can't just stick number there. Whereas if I'm defining variables at the top level of the function, then I can just use local variables like this, and it will basically insert the value there. Yeah, definitely quite easy to make mistakes writing execute queries, and this is basically what quote literal and quote ident are there for. So anything you want to insert into a query, under what circumstances? Well, you could use it with any SQL statement, I think. So you could form an update statement, you can form a delete statement, you could form an insert statement, probably. So it's not super useful in general, but it is possible to build query strings. Shouldn't the second string be, oh yeah, sorry, where did I do that? Did I put a no? Where do you think, shouldn't the second string equals be a yeah, sorry, good point. Yes, you are correct. I had finished. Same up here. Yeah. Yes, exactly. No plus equals or no concat equals. I guess I think there's that concat thing. You could just give a whole bunch of strings as arguments to that and get it to build the query. But, you know, in a lot of contexts, this is the way you do it anyway. You insert the value of something, could be a parameter, could be a local variable whose value you've computed. You're going to insert it into a query if the query is written not as part of a string. So that kind of makes, you know, this would be by far the most common way that you'd form queries in PLP to SQL. Okay, enough on execute. We're back here. Exception handling, I talked about exception and when. So you can catch various kinds of exceptions and you can write handlers for them. And the final thing that I didn't talk about was how you deal with missing data. Did I have a, I thought I had an example of. All right, so sometimes, let's say, I think I'm actually going to write this in a minute. A function like this. So you enter an integer value, which is some kind of key, and it returns the name of the object associated with that key. So assume we've got a table that's got at least an attribute key and at least one other text attribute. All right, so we're feeding in, it looks like an incorrect spelling. Is that, no, that must be wrong spelling of language. That looks better. All right, so we're feeding it a key value and we want to get back information about the name of the object associated with that key. Now, it's possible that that key doesn't exist in the table that we're looking in. So let me just set things up. First of all, All right, so we need to have a text variable. Let's call it name. Imagine that's, and this is an interesting one to select name from some table, call it where, and we probably don't want to just do that. We want to grab a copy of it. So where do we want to select it? We want to select it into a local variable called name. Interesting. Can Postgres resolve the ambiguity of these things? And yes, it can. And if we really wanted to, if we were really worried about that, then we could do that. And return. Right, so this is making the heroic assumption that the key value is actually exists in the table R. What if it doesn't? Well, there are a couple of ways you can handle it. Kind of obvious one is to say, is to use this built-in variable called found, which gets set whenever you run a query. And if found to be true, if you find at least one match to the query, if you find 0 matches, then it'll be set to false. And therefore, if not found, would become true. And I guess the kind of obvious thing to do here is to raise an exception and say something like no such key something like that. And that will terminate the function as well, because it will raise an exception. You don't have an exception handler down here. So it will pass the exception up to the calling function to handle. Happens to be null. Would found still be true? Yes, it would be true, because you found a tuple with that key value. That's really all it's checking, is whether this returns at least one result. I mean, if you want to check that, sure. You could do something like that. It's all right. You don't need Postgres to have a right function, because you're going to, in general, wrap all of this stuff up in a procedural language like Python, and Python is going to do all the writing. All that Postgres has to do is fetch information from the database. And even these things probably aren't particularly useful in the context of a Python script, which is wrapped around this lookup function, because you can't really, from Python, you can't really see the values, or you can't see the exception stuff. So you're better off returning some kind of distinct value, maybe distinguished value. You could return name, even if it's null, or you could return name as null in that case. But anyway, these will kill off the call to the lookup function and produce that message. So if you run this function from PSQL, you'll see these messages appearing. If you say select lookup and you give a key value that doesn't exist. Yeah, all right. I said there are a couple of ways to do that. Another way would be to, if really all you care about is whether the thing actually exists or not. So this isn't actually going to be, so you could do select. So that will always give you a result back. Ooh, except I might need to store the value somewhere. So we assume we got an integer variable called nres. And then you can just check whether the number of results is equal to 0. Then we could do something like this. It's kind of equivalent. Probably other ways to do it. If you knew for sure that you were selecting a value from a field that's not null, so if every R tuple had a name, then I think also this would work. Oh, yeah, why am I? So if you were guaranteed that the name field had been defined in R as not null, then a way of checking that you hadn't actually found a tuple would be to do that. And of course, that would rely on you knowing something about the definition of the table R. If name could be null, then this isn't really an appropriate error check, because there is a key, but it just so happens that the name value associated with the key is null. All right, ooh, that took a while to get through. So that's all I'm going to say about PLPGSQL itself. All right, and all those examples are going to be accessible. Come on. Oh yeah, the other thing I wanted to talk about, all right, sorry, I haven't quite finished, but this also carries over to programming languages, because I've seen people make this mistake a lot. They'll write nested loops when you could easily solve the problem using a join. And they'll also occasionally do a select star from a table and then iterate over the tuples of the table, checking whether each tuple satisfies a condition. Now that's silly, because you've got a where clause where you could check that condition. I won't call it silly. Silly way of doing filtering. So something like this. And once again, assume that we're in the PLPGSQL function for rec in and you may say, hey, who would ever do this? And I've seen it plenty of times. Madness, absolute madness, because you could easily do this as rec And then inside the, oh, wow, inside the body of the loop, every rec would be guaranteed to satisfy that condition. Now, if you had, think about this for a moment, if you had 10,000 records in R and 10 of them had A equals 5, this example of here would fetch 10,000 records and check each individual record for whether it satisfied the condition. Okay, it'll work. It'll give you the right answer, but it's read 10,000 records and had to do some work on each of those records. SQL was designed to do things like that. So if you do this, it's going to be way, way, way more efficient than if you do it like this. So here, in fact, the for loop would iterate 10 times because you'd only fetch the tuples that satisfied the condition. Here you're fetching all the tuples and then individually checking whether each satisfies the condition. So how does the where clause filter the data from the database? Is the data stored? Do COMP3311. They use, well, it's done in various ways. You can have a hashing, you can have B-tree indexes. What else? No, that's about all really. That's certainly what Postgres supports. No. Yes. There you go. Well, we learned about indexes in this course. I will talk briefly about using them and the effect they have, but not about the implementation. Yes, I teach Comp 9315. Don't know why I keep advertising it. It's not intentional. It just so happens. It's so, yes, that's why indeed, why query optimizers inside databases have to be extremely good to make sure that you don't, they're not going to implement the select from where like this internally. If there's a B tree, they'll use the B tree. If there's a hash table, they can use the hash table because we're doing an equality test. In the worst case, they'll be forced to do a sequential scan. So they will end up doing something like that. But that's an absolute worst case scenario. And 99% of the time, they can use some sort of auxiliary data structure to help implement things very efficiently. Similarly with join, I think I've got an example of that. Yeah. So getting back to this employee departments view that we looked at last time. So there's the original thing. It's just getting a list of employee names and department names and the percentage of time they work. And we defined the imp depth in the previous example, so I won't define it again. So that's doing it. Notice an SQL function, kind of obvious, could be done as a view as well. And I think we did that in the last example, but I just want to demonstrate everything as a function. Here's an alternative version of that, where you do the iteration yourself. Okay, that's fine, but notice we're using join. Oh, this mouse is much better. We're using join. And the final scenario is exactly the way I do not want you to do it. Here it looks a bit silly because you're quite close to the database and you can easily see that you're doing it this way. When you're doing it from a programming language, it's often very tempting to use nested loops. And nested loops is the most inefficient way to do a join. And if you're actually forcing the database to do it that way, that's not a good idea. So a database will know how to implement this join efficiently, or it can work out. And there are a whole bunch of different methods for doing joins. But did I just change something? All right, maybe I'm not so impressed with this mouse. All right, so here's an absolute crappy example of doing this. The outer loop iterates over the employees, forming the name, as we've seen. The inner loop takes each employee and works out the departments and percentages that they work for. And once we've got an employee working for a department, we need to find out the department name. Remember that this thing in the table is an ID. So it's a foreign key reference to the primary key of the department's table. Right, so you take that department name, that department ID, and then basically you produce a name. And then you build up the final tuple and you return it. All right, 3 nested loops. Now, one reason I think why people do this is that they're comfortable doing a select on a single table. And if you can do it on 3 selects on single tables, it might be easier than trying to work out how to do a join. Hopefully by the end of this course, you won't think that at all, and you'll always use a join where appropriate. But this is an absolutely terrible way to implement this. A, it's longer and uglier, but each query is, relatively simple. What's that doing there? Oh, goodness, my editing's gone to the pack lately, I think. All right. Yeah, so bad. Don't do it. And in particular, don't try it. Sometimes it's hard to avoid. But in general, avoid it as much as you possibly can, because here you're actually actively working against the database system in the way that it wants to work out these results. If you give it the joins, it'll work out an efficient way to do it. If you do it like this, you're forcing it to do it in an inefficient way. All right, so that was that example. Right, so 2 things to avoid. Don't sort of implement what the query processor can do perfectly well. Oh, good. What a perfect point. Oh no, I can keep going a bit. Will I? Yes, I will. Just a few more minutes. All right, aggregates. So we've seen aggregates plenty of times. Ooh. Let's see, what tables have I got now? I've got to run my server. This is just a junk database that I stick random stuff into. Oh, yeah. And a really stupid query. That's nice, summing up all the ID values, pretty meaningless. I get, more useful might be to find what's the maximum ID value. All right, so both sum and max are aggregates. And what aggregates aim to do is take a column of values like we got here and reduce it to a single value. So here we reduce it to the sum of these values, which is 55. In the second example, we find the maximum value in this list. And so we've reduced the list to a single value. My, that was lingering on, wasn't it? All right, so another example, getting the average mark from 3311 would be a common thing to do. All right, how do we do this in database context? We know for sure that a database system can iterate through a list of tuples. And what we need to do to produce a single value at the end is to somehow keep track of what's going on, look at each individual tuple and incorporate that in some way in the final result. In this case, we're going to have obviously a running total. So first time we'll see 1, then we'll add 2 to it, then we add 3, then we add 4, blah, blah, blah. So to generalize this, you can think about the way aggregates work is they start, or they use some kind of state to keep track of what's going on. So you start with an initial state, you iterate through all of the tuples in the table. So this is effectively what this says. Get all of the tuples from X, and for each tuple, do something that updates the state using the value from that tuple. And once you've finished looking at all the tuples, you've got your final state. The state may include a bunch of values. Certainly, if you're doing something like average, you'd need to include a count of the number of tuples and the accumulated sum. And then to get your final result, you need to divide the total, the sum by the number of values. So doing something with the state to produce the final result. Often that involves just extracting one component from the state, but it might also involve doing some calculation on the values that are currently in the state and then returning a single result. Always, though, we're going to get a single result at the end of this. All right, Postgres allows you to define aggregates like this. A lot of other databases don't support user-defined aggregates. Postgres is pretty good in this respect. And also, its mechanism for defining aggregates is relatively straightforward. So we have to give a name to the aggregate, sum, average, count, whatever. This is telling us the type of values that we're aggregating on. Now, I've been talking about it as if it's a single column, but the base type could be a tuple type as well. But for the sake of argument, let's just think we're dealing with a column of integers. So the base type is integer. All right, we need a function to update the state. In the case of a sum, what you'd be doing is you'd be taking the value from the current value from the current tuple, and you'd be adding it onto the accumulated total each time. So you do that for each tuple, and it gives you your final result. The state type could be a tuple type, or it could be an atomic type like integer. So if you think about sum, yeah, it's just going to be an integer which you keep updating. And an initial condition, so an initial value for the state object, and then a function to finalize the result, to produce the final result given the final state. So if you define all these things, you've got yourself a new aggregate. You don't need to specify an initial condition. For some contexts, that's all right. if you're relying on the initial value not being null, then you better give it an initial type. And the final function is also optional. So if your state is actually producing the results as you go in a single value, then sure, you could use the identity function. I guess, I mean, I've kind of been assuming that we're producing a single value, but also there's no reason why you couldn't produce a single tuple given a whole bunch of tuples. So maybe you might want to do something like it's not actually quite what I had in mind, but this is actually using two aggregates. But if you really wanted to, you could define a single aggregate that produced that final tuple with max and min. Right. Right. So we did notice when we tried to write a factorial function using the sequence table, the sequence function, which generated a table of integers, that there wasn't a product aggregate. There's a sum, there's average, there's standard deviation, there's a whole bunch of stuff, but there's no product. So how do we define a product aggregate? Eggs.sql, that's where I put this. All right, product. So what's the state type? Well, in this case, it's just the running product value. So we can get by with just a single integer. What's the initial condition if you're doing a product? So you're starting with the initial state and you are incorporating other values into that state. For a product, we need to start with the value 1, correct? The final function, well, since we're forming the result in the state, and the state is just an integer, then we don't actually need a final function at all. So these functions have to be well, they have to be Postgres functions. Typically, they'd be written in PL/PGSQL, could be written in SQL, I guess. All right, so, oh, and I've forgotten how much you have to specify the function. I think, so we're accumulating a product. I think you have to give a type. Pretty sure that's what you need. I'll have to go and check this during the break. All right, in any case, create a replace function. Typo. Accum. Oh, I'd actually have to take two things. Two integers. So it's going to take the current state and the next value to incorporate into the state. Well, hopefully next will be okay as in this case, I think it's as simple as language. You actually do it as an SQL function, because all you really need is two. And I'll get rid of that. So to modify the state, all you need to do is take the current value of the state. Maybe I should call that something different, call it prod, I guess, kind of makes more sense. And multiplied by the next value that's coming in from the table. And PostgreSQL will create an aggregate for you, given all that information, and then you can just start using it just like any other aggregate. And let's check whether I got that right. Let's take that test database, try and create all that stuff. Damn, syntax error. Select. Maybe I shouldn't have put the same beauty. Let's see. Oh, right. I'm editing it outside Postgres, so let's quit from Postgres. Reopen this. That should be enough. If not, if this doesn't work, then we're going to have a break and I'll fiddle around with this. I'm not sure that I captured that. I feel like as, thank you, as $, yes, good point. I feel like commenting all this stuff out. Notice you can use C-like comments in Postgres. That's not standard. So then I can just fiddle with test. Then I can just load the whole thing each time. What do I do? I think I put a comma after. Yeah, I did. Postgres doesn't like commas just before parentheses. And you might say, what the hell are you doing? What is it doing? It didn't say create function. What it's actually doing, it's waiting for a semicolon. Oh, it did create the function already. Yeah, how stupid, printing out the comments like that. All right. I got this here. I do. Chance of this working are 1,000,000 to 1. Damn. What? Oh, yeah, well, certainly if I don't give the parameter. Well, so no function matches the given name and type. Really? Odd. I thought it did exist. Oh, it's called product, you goose. Notice that when you write a function like this, if you don't specify a name for the attributes, it just inherits the single, it inherits the name from the function. and kind of treats that as the damn. Well, that was good. I wasn't expecting that to work, but there you go. Obviously, I haven't forgotten how to do it. Okay, so all we need to do, supply a function that takes the current state and accumulates the product, current state, current tuple, and incorporate the current tuple, which I've called next, into the new state and gradually build up the build it up that way. All right, let's have a quick break and I'll have a look at the other aggregates here. Okay, so I pause recording. Resumed recording. Right, so that was doing a product aggregate. Right, the next one, and I'm not sure that I've actually I didn't check whether this actually worked, but Postgres has some generic types. And I think numeric is not quite a generic type, but it encompasses a few of the other numbered types. But I think if you've really got absolutely anything, then there's a pseudo type called any type. All right, so we probably can't call it count. Better call it my count. All right, so the type is the state type is simply going to be a number because we're counting things. The type of the values is going to be this. It can be any old value at all, but certainly the state is just a counter. Initial condition, we're accumulating a count, so we initialize to 0. And once again, I don't think we need a final function. We can leave that out. All right, now we've got to write the function to count. I can't call it accumulate. I don't know. Add 1, which takes state. Takes a state object integer and any old kind of object, whether it's a tuple, whether it's an integer, whether it's a real number, whatever, and basically just says, hey, here's another thing. So add that to the accumulated count. Hopefully this will work. Remember to put the as this time. This time I'll do it as a PLPT SQL function just for fun. I could do it as an SQL function as well. And all we got to do, we don't care what the object is. We just need to know that there's one more of them. So that's all you have to do. Increment the counter. And hopefully that will work. I can't remember whether there's create or replace aggregates. We'll probably get the error about recreating the product aggregate, but let's see, we can ignore that. Product already exists, blah, 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 fine. Syntax error, it'll need create. Did I forget to put a semicolon somewhere? I did. Oh. All right, type any type does not exist. Oh, I was sure it did. Oh. Let me check the Postgres manual. Okay. Fake. Oh. Rave. No, I don't really care. Postgres type system. It's probably the one I want to look at. Base types, pseudo types. Can we use record? No. Oh, any element. Oh, okay. All right, there you go. There's a whole bunch of any types. So the one I want, I think, and I'm not sure whether it's, oh, yes, I see where it came from. Right, once again, check the prompt. It's got a minus there, so it means it's waiting for a semicolon. Greater replace. I forgot what the error was. Oh yeah, what's these? God, I thought I was writing C code. Shocking. Add one. Oh, and any type. Element. Okay. All right. Oh, and it's gone green, so it's got a clue that it's a reserved word or a keyword at least. Did I? Oh, yeah, I've made the same mistake there too. Fix that up for later. It's commented out at the moment. Oops, and here's a mistake I fell for before as well. Yeah, thank you. Create function, create aggregate. Right, we got this error here because you can't create or replace. I suppose I should check that. I hope you're watching what I'm doing at the Postgres manual so that you know how to navigate your way around. Here, SQL commands extremely useful. Create aggregate. So I just search for create. Oops. Create. There's a lot of creations you can do. Oh, you can do create or replace. Oh, good. No, should have done that. I'll add that. So what do we got? We've got count. That's all right. Oh, my count. Huh. I've got that. So let's see. So the function my count does not exist. Isn't that what I called it? That is what I called it. And it seemed to create it okay. That's a bit strange. Anyone spot an obvious silliness there? Create aggregate my count. And the function exists. I think you can check what aggregate you've got by, no, you can check access methods by doing that. Maybe that. Yeah, my count. Argument type, any element. If you want to find out what Brin B3 gin gist hash heap blah 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 all mean, do COMP3311 or read some Postgres documentation. Let's see, what am I looking for? Oh yes, I'm trying to find what tables I've got here. So what's this? All right, so let's try. Okay. Maybe I was asking the query incorrectly. Oh, right. Okay. So it's not quite as smart as it seems. Any element might mean any single atomic value. So as long as I don't try to feed tuples into it, it's probably all right. So it simply counts the number of such objects, and it's going to not, oh, here's something. I bet this doesn't work either because the actual count, well, it's a bit silly because they're all distinct. I just wanted to see whether, oh, okay, so it does work. Cool. All right, and the final one was to write effectively something like string ag. Right, so the state type is text, which is forming a text string. The initial condition, here we need to set, if we leave it as null, then the final result is always going to be null, because if you concatenate something with null, the result is null. So we have to set it initially to an empty string. And here I'll use a final func. A final function. I'll be a bit sloppy with the way I build the string. Let's call this. All right, and so we need a function to join. So our state is a string. So we've got the string that we've gradually accumulated. By the way, I should have said we're doing comma separated. So here we don't have the option that string ag does, where you can specify a separator. We're going to keep it a bit simple. And we need to write two functions. Right, this function takes the state, which is a text string. What is it called? Stats. It's not called stats. It's called state. And the next string to be incorporated, which is also a text string. And having incorporated them, we add them together. Whoops. And we return a new state, which is a longer string. And let's do this as a simple SQL statement because we can. And we're going to stick a comma at the front to separate the current string from the next thing that we're going to add. And I need to say what the current thing is, and then next. Don't put a semicolon, you fell for that before. All right, so we take the current string, put a comma, and then put the next string after it. So we're gradually going to concatenate things. Let's, I'm kind of preempting a bit. Better get rid of that. I think that's probably enough for the time being. Let's see what happens if we use this one. Did I have an error just from the aggregates? I should have done create or replace. Silly me. Oh, and I've got that extra close comment in the end. It doesn't matter. I'll fix that. All right, so select cat. Select cat name from X. So this should concatenate all those name strings from the X table, which it does, except we've got a comma at the start, which we don't want. How do we get rid of that? We use the final function to strip it off, hence why it was called strip. There are other ways to do it, to not put it there in the first place. In the case, where we've got an empty string, you couldn't do that with a SQL function, but you could do it with PLPG SQL. I'll show you that version in a minute, but really just wanted this so I can show you a final function because none of the others have had final functions. And this one can also be done, and there's a substring function in Postgres whose details I can't remember off the top of my head. Oh, and here's look what else you can have with an aggregate. You can have tons more stuff than what I've showed you. What am I looking for? I'm looking for substring. That's right. Pretty sure it's called substring. It might be called substr. Pattern matching, substring, string functions and operators. That's the one I want. Whereas substring, all right, takes, no, that's not the one. Where's the one with, this, all right, substring from, for, and they're optional. So if I want to start from number position 2, which is what I want to do, this example here looks nice. And if I don't specify the 4, then it'll just take the rest of the string starting from a particular position. And in this case, the positions are numbered starting from 1. So not from 0. So substring of the state starting from position 2. All right, let's see if that works. Oh, no, that's harmless. All those errors are harmless. All right, we can back up to select cat name from X. Because I hadn't. Let's get rid of that. All right, cool. And there we have the string with the bloody comma still at the start. Why is it there? I thought I'd got rid of it. Oh, good point. Thank you. All right, so those error messages weren't harmless. This will fix them all up. Or replace, what the hell is or? It's like iron ore. Create or replace. Create or. Same thing here. All right, no error messages. Nice. Okay. Hopefully it will work. I don't like the way select cat name from X. That's one I want. Yay, it's gone. All right, so that's one way to do it. The other option would be in the that in the join function, you don't write it as SQL. I'll just do the alternate join. Still got the same function signature. Right, realize function that. LPG-SQL in. I think I could actually have done this with an SQL function, but this is kind of more obvious. If state is the empty string, so this is the first one that we've seen. I think those parentheses are unnecessary. Then state equals next. I just get force of habit from writing C code. Quick as type. They have a special case for the first time you call this function. So, I mean, you can argue that this one is slightly annoying because it has to do this if test for every iteration or every call to join, even though it's only going to be relevant once. And if what you were doing here was something more complex and more expensive to compute, then maybe you wouldn't want to keep calling this if test. If the if test itself was expensive as well. So you could argue, well, we just do it the sloppy way, the sloppy, efficient way, and then we clean up at the end. Might end up being more efficient. All right, so that's aggregates. Well, let's see, I don't need that. All right, next thing I want to get onto is talking about constraints. We've already looked at tons of constraints already. The type that you give to an attribute is a kind of constraint. It tells you what kind of values can go there. You can restrict it even more by putting a check clause on it, or you can use a domain, create a domain. You can even add constraints that compare values of different attributes in a table. So you might have a constraint which you have to put at the end of the table. If you had two values, X and Y, and you wanted to insist that the value of X was always greater than the value of Y, then you can have a constraint that checks that condition. And the whole point of constraints is if you try to insert data that doesn't satisfy the constraint, i.e. is in some sense incorrect, then failing the constraint means the change that you're making to the database doesn't happen. So you can't insert the bad tuple. So, you know, we looked at that in one of the prac exercises. Might have been number 2, maybe number 3. And we've also seen referential integrity constraints. So basically you're not allowed to insert a tuple with a foreign key value unless that foreign key value exists in the target table. So they make sure that those kind of connections between tables are valid. So you can do a lot of stuff within a single table. You can do referential integrity checking between tables, but there are other kind of constraints that might involve conditions that relate multiple tables. And you can't express them in Postgres. So here's the kind of thing I'm thinking of. So we've got accounts that are held at particular bank branches. And if we want to define the assets of a branch as being equal to the sum of all the balances of the accounts that are held at that branch, we could write a test like this. So we want to check that for all branches, the assets value at a particular branch B is the equal to the sum of the balances of all the accounts held at that branch. Okay, so that's not a referential integrity check. It's a condition that holds across, well, in this case, just 2 tables, but you could involve multiple tables in conditions like this. So there's a notion here that we're checking we're looking at all branches and we're making sure that all the branches satisfy this condition. And if that's true, then that's okay. The data is valid to the extent that it satisfies that condition at least. Now, SQL, the SQL standard, does define a way of specifying global constraints, and that's an assertion. And if we wanted to have an assertion that students in any UNSW course, you can't have a course that has more than 10,000 students in it. CSE might be bumping up against that if our enrollments continue to grow at the current rate, but hopefully not. Sure, if you extrapolate the growth rate, compared to 29, how much has gone up by 30, 40%, something? I'm not sure. If you want to find out things like that, ask Andrew Taylor. He goes and writes little scripts that he would have written in 2041 to compute all those kind of things. All right. So this is the actual syntax. You can create an assertion, you give it a name. The reason you give it a name is because if you make changes to the database and the constraint no longer holds, it's going to give you an error message which includes the constraint name. All right, and then you need to check a condition. Now, in the previous example, we were checking that some condition held for all of the tables. You kind of have to flip it around a little bit and ask a query that checks whether the condition is violated by some tuple in the, well, some combination of tuples in various tables. And if it is, then the assertion doesn't hold. If you can't find any example in the database where the condition is violated, then the assertion succeeds. So what you're basically looking for, try and find some some counter examples, if you like. And if there does not exist any counter example, then the assertion holds. So expressing assertions is, a little bit twisted around logic. Something to notice about this, every time you change the courses table, you got to check that this condition still holds. It's certainly every time you change the enrollments table, you got to check that condition to make sure it still holds. And if you have a more complex assertion that involves multiple tables, every change to any one of those tables requires the assertion to be checked. And in fact, you got to keep track of all the assertions. You got to know which tables the insertions that refer to. And Selena, you've hit the nail on the head, because all of this work to check these kind of global assertions is extremely, or the cost is extremely high. So SQL databases don't implement it. So it may be there in the standard, but I don't know if we're going to look at the Postgres docs, and I'll be annoyed if it is there. Let's go back to the SQL commands. I bet we can't find a create assertion. Thank goodness. Phew. All right, so Postgres doesn't implement it and nobody else does, because it would make the database so inefficient, so slow. Every change causes lots and lots of checking. And the reason it's lots of checking is you've got to check basically everything and make sure there are no counter examples. So we don't implement assertions. What can we do? Triggers come into play here. All right, so they can do some of what you'd like to do with global constraint checking. They can also sort of bypass the need for checks by making sure that the data ends up satisfying the constraints that you want. So you can check, if you're trying to insert a new enrollment into a particular course, if it's greater than, if that would make the enrollments greater than 9999, then you prevent it. So what are triggers? Triggers are functions. I've called them procedures. They're stored in a database, and they're invoked not by you saying select function name and a bunch of arguments, but they're invoked automatically whenever you make changes to the database. And here you can be a bit more specific. Does it mean that I'm talking about a query function is acceptable? No. Not if some of your queries take 5 minutes to run. That's not acceptable, even if you pass all the tests. So a query that takes too long to run, even if it produces the correct result, is going to be penalized. 3 seconds for the size of database we're dealing with here is ridiculously generous. I could have made it 1 second. Yeah, exactly. Yeah, it's 3 seconds. So if you can't get it done in 3 seconds. Yeah, sure. I agree. But I'm being generous, aren't I? Allowing 3 seconds per query. Right, getting back to triggers. So what can you do with triggers? You can use them to maintain summary data. I'll show an example of that in a minute. You can use them to check schema level constraints. Since they're only invoked under certain circumstances, it's not like assertions which are going to be invoked every time any of the underlying tables gets changed. So you can be a little bit more focused. And you can also perform updates that involve multiple tables, and you can use those to force the assertion conditions to hold. So triggers basically triggered by an event, you test a condition, and then you execute the procedure if required. Now, the semantics of triggers are a little bit subtle, and triggers can be executed. So triggers are invoked in response to an update event. Let's say we're talking update, so you're changing values in the database. You can invoke the trigger before you make the change, or you can invoke the trigger after you make the change. So this little thing here shows what actually happens. So as soon as you type update set, salary equals salary times 1.1, give everyone a pay rise. Before you run that query, the before triggers are going to be executed, if any. SQL going before git, who coined commit, SQL coined commit. Slightly different thing anyway, I think. So before triggers run before the operation takes place. Regardless of whether triggers exist or not, you're still going to do all the standard database constraint checking, check the value of a type, sorry, not the value of a type, the value of an attribute being appropriate for that attribute. So it can't be outside the range of allowed values and so on. Check that referential integrity constraints hold all the standard constraints that we've talked about so far. If they hold, then and if there are after triggers, then they'll be executed afterwards. So there's these 3 stages of what happens when you actually make a change to the database when triggers exist on the tables that you're changing. All right, now while you're inside a trigger, you actually have access to the tuples that are being changed. With an insert trigger, you're inserting a new tuple, so all you have access to is the new tuple. Notice here there's a little quote, which means that the thing that actually gets through to the next stage of being inserted can be different to the tuple that we originally tried to insert. And maybe that's because the trigger function itself made some changes to the tuple to make sure that various constraints would hold. So you're actually allowed to change the tuple inside the before triggers. So whatever tuple is about to be inserted into the database, which I've called U prime, will be inserted into the database in the usual way with all the normal constraint checks. And then after if there are after triggers, they will also be invoked using the new tuple. If you're deleting, then there is no new tuple. There's only the old tuple, which is about to be removed from the database. Before triggers will have access to the old tuple, the standard database constraint checking, I guess, checks the old tuple. Why do you need to check it? Because you might be removing a tuple that's referenced via foreign keys from other tables. So, if we've got a table that involves courses and we've got enrollments, you can't just go and remove a course tuple if there are students enrolled in that course, for example. So in any case, if there are before triggers, they're checked. Standard database constraint will check anything that also needs to be checked on the old tuple being removed. And then if you've got after triggers, update triggers are slightly more interesting because you've got the old version of a tuple, the original version of a tuple, and you've got the updated version of the tuple that you can look at. So you can even compare the two things. And if you discovered that your update hasn't changed the tuple at all, then you might say, you haven't changed anything. Why are you bothering with an update? So an update can access both versions of the tuple. It can actually change the new tuple. So new prime. When you're doing the standard database constraint checking, you still got access to both those tuples if the database needs to check anything about them, and also your after triggers can be executed after the standard database constraint checking is successful. If the standard checking fails, you never get to this stage. With views, or you still need to drop views if you want to change the column. Yeah, you need to drop views if you want to change the column names. That was kind of two questions, really. Does it update work? Oh, I see. You're trying to update the name. Yeah. Well, in theory, if you knew something about the catalog tables, maybe you could do an update on the catalog table and change the name, but not quite relevant. All right, so that's what happens if you've got triggers involved. And just to make the point, the before trigger can modify the value of the new tuple. And I'm going to stop soon, but this is how you make triggers, and we'll have a look at some examples after week 6. If we're doing extra constraint checking, yeah, sure. It's not necessarily better to do it afterwards, but you're right. There are certain things that you don't want to do before you do the standard checking, because there's no point doing them if the thing's not going to be added. If the modified tuple is not going to appear, you don't need to do those checking. But there are some things that you need to wait until all the constraints have been checked, all the standard constraints, before you do more. And it's not just checking either. I might have been giving the wrong impression, but the trigger procedures can do anything. They can modify other tables. They can compute values. And when you think about, if a trigger can modify another table, what if the other table has a trigger? Well, we'd have cascading triggers, and hopefully you don't have circular cascading triggers. Yeah, indeed. All right, it's 11:05, so I'm going to stop there and show examples of triggers at the start of week 7, and then get on to Python Psycho PG2. Is there a video to install it? And install Python? No, not made by me, but I'm sure there are tutorial videos out there on the web. I just assume it's installed. Well, good, you got Python installed. I mean, you might find that it's already got, yeah, exactly. And you're not spelling psychopg2 correctly. It's yeah, thanks. All right. Anyway, enough. I'm going to stop recording.